By the 1970s, the lessons from Vietnam had really sunk in. The next generation of fighters, well, they would be different. They wouldn't just be faster and more powerful. They would be smarter and more agile. This led to the lightweight fighter program, which produced two legendary aircraft, the F-16 Fighting Falcon and the F-18 Hornet. These planes, which came to be known as Teen Series fighters, represented a major shift in design philosophy. They were built from the ground up to be exceptional dogfighters, but they were also packed with advanced electronics that gave their pilots an unprecedented view of the battlefield. This was honestly the beginning of the digital revolution in the cockpit. One of the key innovations was the fly-by-wire system. In older planes, the pilot's controls were connected to the wings and rudder by a series of cables and hydraulic pistons. But in a fly-by-wire aircraft, the pilot's stick inputs are sent to a computer. The computer then interprets what the pilot wants to do and sends electrical signals to the control surfaces. This system allows for designs that are aerodynamically unstable. An unstable plane is much more maneuverable, but it's impossible for a human to fly without constant computer assistance. The F-16 was the first major production fighter to use this technology, giving it an incredible agility that pilots really loved. The cockpit itself was transformed. The old steam gauge dials were replaced with screens. The head-up display, or HUD, became standard. This was a piece of glass in front of the pilot that projected critical information like speed, altitude, and targeting data directly into their line of sight. So, they no longer had to look down at their instruments in the middle of a fight. Later, multifunction displays, or MFDs, were added. Small computer screens that could show radar information, maps, or weapon status with just the push of a button. The pilot was becoming less of a stick and rudder operator and more of a systems manager, really a battlefield commander in the sky. This new generation of fighters also had much better look-down/shoot-down radar. Older radars had trouble spotting enemy aircraft flying low against the clutter of the ground. But new pulse Doppler radars could filter out this background noise and pick out a fighter flying below them. This, combined with more reliable missiles like the AIM-7 Sparrow and the AIM-120 AMRAAM, meant that fighters could engage enemies from beyond visual range with a much higher probability of success. The combination of maneuverability, advanced electronics, and better weapons made jets like the F-15 Eagle, a larger air superiority fighter from the same era, the undisputed kings of the sky for decades. For as long as there had been fighter planes, there had been a contest between the hunter and the hunted. The development of radar during World War II gave the hunter a huge advantage. Radar could see through clouds and darkness, detecting approaching aircraft from miles away. For decades, the answer to radar was to fly faster and higher, or to use electronic jamming to blind it. But during the Cold War, a few brilliant engineers began to ask a different question. What if, instead of outrunning or jamming the radar, we could just disappear from it altogether? This was the beginning of stealth technology, or what engineers call low observability. The basic principle of radar is simple. It sends out a pulse of energy, and if that energy hits something, it bounces back to a receiver. The size and shape of the echo tells you where the object is and how big it is. The goal of stealth is to prevent that energy from bouncing back to the receiver. The first way to do this is by shaping the aircraft in a very specific way. Instead of smooth, rounded curves that scatter radar energy in all directions, a stealth aircraft is made of flat panels called facets, angled to deflect radar waves away from the source. But shaping alone wasn't enough. The aircraft also needed a special skin. Engineers developed radar-absorbent materials, or RAM, which are like a high-tech paint or coating that can actually soak up radar energy and convert it into a tiny amount of heat. This material works like the foam soundproofing on the walls of a recording studio, but for radar waves instead of sound waves. Every part of the aircraft had to be designed with stealth in mind. Engine intakes and exhausts, which are major sources of radar reflection, had to be hidden. The cockpit canopy was coated with a thin, transparent layer of gold to deflect radar waves. The result of all this work was an aircraft that was not truly invisible, but had a radar cross-section that was incredibly small. A conventional fighter might look as big as a barn door on a radar screen. A stealth fighter might look as small as a bumblebee or even a marble. This meant that an enemy radar might not see it at all, or if it did, it would be so late that the stealth aircraft would have already completed its mission. This was a game changer. It was the biggest leap in air combat technology since the jet engine itself. It promised to make even the most advanced air defense systems obsolete.